All right, here we are at 4:30. We have Alejandro Tellez and Federico Unger. I hope I'm saying that correctly. If not, I apologize. These gentlemen are scientists from the National Polytechnic Institute at the Monterey Institute of Technology and Higher Education. Welcome, gentlemen. Let's go right ahead when you're ready.
Okay, thank you very much for your kind introduction. So here we are. We would like to present to you throughout this session the advancements of the Bioculture Space Garden team that's conformed mainly of two people, Alejandro Salinas Tellez and Federico Granados Unger. And regarding current research that aims to create a solution for one of the greatest challenges in the space sector, that is the production of food for long duration missions. So why is space exploration so important? First, because obviously it creates jobs for engineers, scientists from many disciplines, architects, law professionals, physicians, and many others, just to name a few. And people coming from different fields of study and countries can take part in this upcoming space revolution. And by doing so, new technologies, scientific discoveries, and advances in medicine that are useful for both space and Earth can be generated. In addition to this, new ideas related to the architecture and habitats for future colonizers of Mars and other planets will have an opportunity to turn them into reality, making the colonization dream possible. Okay, now, what has the ISS done for humanity? Firstly, for example, we have cancer research. For example, a team of Australian researchers on Earth exposed ovarian, breast, nose, and lung cancer cells to a microgravity simulator for a 24-hour period, and found that it caused 80 to 90% of them to die. So the scientists believe this is because a lack of gravitational force on the cells that influences how they communicate with each other and makes them unable to sense their surroundings, something they call mechanical unloading. They mentioned they would be sending a confirmatory experiment this year above the ISS. So this is very exciting in that aspect. In addition to this, for example, in surgery advancements, astronauts in the International Space Station have performed, for example, laparoscopy to rats to repair the organs inside their abdomen while in microgravity, right? So they are doing some advancements in how to do these experiments in that environment. Also, we have some human behavior experiments on microgravity. For example, the experiments of the twin study of the Kelly brothers, where they looked at the metabolism, genetics, and cognitive performance of the true astronauts. We have also some food research being done. For example, at the NASA Johnson Space Center, Space Food Systems Laboratory, where they have where they examine several factors to develop space food, right? The astronauts try it, and after they pass some tests, they can their menu goes up in the station. And we're gonna also have some study related to the eyes, for example, because in the microgravity, the fluids on the body of the astronauts tend to shift outwards to their heads, which puts pressure in their eyes, causing some vision problems, right? So they're trying to know what's going on in that study. So additionally, for example, what has happened, what research has happened related to the space that has benefited humanity here on Earth, right? For example, we have in the upper left image, Internet of Things, which has made life really easy for us, right? It has helped us to have some home appliances, for example, connected to our cell phones, like our fridges, for example. And on space, there has been ambitious projects such as the Internet of Things Everywhere on Earth project, that is focused on the telemetry or the communication between a satellite in the ISS and the terrestrial infrastructure, right? Then we have, for example, as we have said, several advancements in medicine. For example, some vaccinations against Salmonella and Staphylococcus aureus, two very dangerous microorganisms, has been done up in the International Space Station. And also several companies on Earth, for example, during the current pandemic are aiming to send experiments to the ISS with the objective of discovering new drugs or vaccines against the COVID-19 virus, the COVID-19 disease, sorry. Also in the material science and infrastructure, there was a recent news that told that a group of researchers have found that by combining chitosan, that is found, for example, in mushrooms, in crustaceans, in fish, with Martian regolith, a chitinous material that they call biolith can be created that could be used to 3D print from basic tools to even rigid shelters on Mars. This could be applied here on Earth to 3D print homes for people living in rural areas, for example, that are living under extreme climate conditions, right? Also, in the image in the center below, we can see for example, there was a news in 2018 that told that Chinese space engineers and scientists that were experienced in the space sector used that knowledge to create a smart suit for firefighters in that year that had the capacity to cool down by itself and to help them to track their location at all times, right? And then in the far right, the below bottom image, we can illustrate that, for example, the ISS has developed some remote ultrasound systems that allows for the astronauts to conduct their own ultrasounds and transmit the data directly to a live medical team on the ground, right? And this technology is being adopted in many hospitals on Earth. So we have many applications of this on Earth. Then what is the characteristics of Mars? Here we can see some of them. And well, Mars is full of, for example, of canyons, valleys, and mountains that scientists believe, based on what they know of studies here on Earth, that were carved by lots of flowing water a long time ago. Then after, once this happened while Mars has had gravity, right? But after the loss of its atmosphere, product of the loss of the magnetic field's protection, this water drifted off into space, evaporating, leaving some of it frozen on this planet. But we have the question that, is this water in the planet? Was it there for long enough to life to develop on it? And this represents one of the main questions that scientists that they have pushed them to go to Mars, right? But there are many others. For example, one of the most important, mentioned by Elon Musk yesterday, is ensuring the survival of our species. Right? If the human, for example, Hawking said, if the human race is to continue for another 1,000,000 years, we will have to boldly go where no one has gone before. Right? We have to go to Mars in order to avoid a catastrophe of global proportions to wipe us from the face of Earth. Right? Also, Mars is an ideal target for our next home because, for example, it has almost the same length as Earth's, and it has water, ice on its surface, as I just mentioned. And for example, Venus and Mercury are too hot. And for example, the moon has almost no atmosphere to protect the residents from destructive meteor impacts. So we have to go here for our next frontier. So the need for example, for the human colonization of Mars, its low gravity, which causes liquids like water to evaporate, and the need of the production of food for long duration missions have given rise to the Bioculture Space Garden project, which consists of a device that will enable the growth of diverse plant species for human consumption on the planet. The device has on the outside a heat insulating bag made of neoprene and denim that protects its surroundings from the contamination with pathogens. On the inside, it has a biodegradable bag that compacts the substrate and other components. It has little hoses that provide the plant with the different solutions it requires. The device also has humidity and temperature sensors that form part of a monitoring system that represents a novelty when compared to the current approaches on space gardens. Now, in addition to what has previously mentioned, we have also developed a continuous control drawer that complements the Bioculture device with the objective of generating a safe and sustainable environment for the plant species to be cultivated. It's equipped with a ventilation system, as you can see in the image, a system for the monitoring of gas exchange of CO2 and O2, lighting in different light ranges of the electromagnetic spectrum, and walls that help the system achieve heat insulation and absorb any leaks that may present in the experiments. Also, well, the initial selection of species to be tested in this system were lettuce, potato, and corn, where we achieved not only a successful sowing and germination of their seeds, but also the complete development in our system. These species were selected for their high nutritional content when compared to other plants. As you can see in the table, the values of proteins, carbohydrates, fat, and water are very good for these plants. We have decided additionally to incorporate amaranth and quinoa in our future tests, as they're both considered part of the superfoods category because of their unparalleled nutritional content. For example, we would like to highlight the relevance of amaranth in this system, because this crop is among the vegetables with the higher protein and omega-3 and 6 fatty acids content. The quality of both of these fatty acids and proteins is very high, achieving very high levels of digestibility. In addition to this, it's very resistant to adverse environment conditions, which could prove useful on Mars, obviously, because of its horrible conditions as we have seen before. It's considered by NASA as a CELLSS crop, as it removes CO2 from the atmosphere while giving food, oxygen, and water to the astronauts. Okay, the fact that Mars gravity is 1/3 of the Earth, as we saw previously, the transport of nutrients throughout the plant is affected. The design of the Bioculture device helps the plant with this process by compacting the nutrient solutions in its internal bag. Specialized nutritive solutions have been chosen to further facilitate the nutrient uptake and development of the plants being cultivated in the system, as we will see in the next slides. Okay. We know that on Earth, high levels of salinity and low levels of water in the soil are problematic for the growth of plants. Given that similar conditions are present in the Mars regolith, in addition of toxic chemicals such as the perchlorate salts, the development of novel plant cultivation techniques such as those achieved by the Bioculture space garden are necessary. There, sorry for the Spanish. We just took these images for their illustrative properties. In the left, we try to put into perspective the viruses and pests that can attack our plants, right? So we have many, such as caterpillars, mealybugs, aphids, and several types of worms that can cause great damage to the plants. This can reach other planets if we're not careful enough to sanitize the plant material that will be taken there in rockets, right? And they can contaminate the soil if they're planted directly in it and spread it through other plants. We try to avoid this with the external back of the Bioculture system. In the left, we try to put into perspective the problem related to the nutrient requirement of plants, because each plant has very specific nutrient requirements. if we supply them with an excess or absence of the nutrients they need, several symptoms of damage to the plant, such as chlorosis, that is the leaves of the plant turn yellowish, necrosis, that it's parts of the plant die completely, or changes in color, such as from green to brownish or reddish, could appear. So we have to get to supply this each of these plant species with the nutrients, the specific nutrients that each plant require for their optimal growth, in order to avoid problems like this.
Thank you. Is my turn. Thank you for welcoming my partner on this convention on the exploring and conquest of Mars. Tellez started. As my partner, as I already mentioned it, space exploration requires technology that suits its conditions of other worlds for exploration and colonization. Bioculture is one more solution to big challenge of space exploration, but how it works. Basically, its operation is compact everything inside and the back. The treatment given for seed germination consists of different processes on of team. Is the use of leukocytes and signs that they have a high level of nutrients. This related its product from the filtration of nutrients into soil, and this liquid is used to reheat the soil. As you will see in the data table, we can find the main nutrients is contained in the solutions. Cannabis is element and magnesium and boron, carbonum. And the benefits is so important. Is okay. Selfie. The next, please. The next page. Okay. Cell-free water should also be used to not generate alterations in the plant growth, and the hormonal solution for alkalinity growth on the benefits of using the solution in the biological regeneration of the soil. Science the use of leaches increase the amount of microorganisms. This solution used must go through some tests before they can be used for irrigations. The most important test is pH. By what? If the nutrient solution increase your pH, it can alter plant growth and nutrient transport, so continuous review of the solution is necessary. The most also by carrier analysis of soils present in the water, this can also affect the ground and transport into plants. As you can see in the images, can you observe two sensors, one of pH and other to TDS and the white, and pH is the yellow, is the indicating optimal ratings within the range of operation. It is very important to check continue the pH and the TDS on the solution to imply. The next, please. But what's happened when we don't have enough light for our plants? We need artificial light with a certain width of colors emitted by the sun that the human eye cannot see. Here are some graphs where the light emitted by the sun is shown, and only need white, blue, and the red forming and the purple color. In the graph and on the right, we can observe the emission of the light inside and the control box. Let's me start. This is a graphic. The graphic the left, please. Start it. Okay. Yes. I see the functionally and the light and the control box inside. This hi. This is important for plants for to growing for this is okay. The next, please. Yeah. As a conclusion, we can say to Bioculture is an insulated and safe system that allows the rapid growth of plants and difficult environments. In the imaging, we can observe to rapid growth in the plants in the 3 days, taking into account that is deprived of sunlight and the normal growing conditions. As my partner mentioned earlier, the selection of the species or seeds is due to its high resistance and difficult environments. In the imaging, we can observe the high iron revenue necessary for the human body. The next, please. We are here. We can see another the images of the current plants grounds that were made in the left imaging where you can see the in vitro grounds of species, but it still lacks germination since imaging was taken a couple of days ago. In the other 2 images, we can observe germination trains with ravenous and lettuces. It is important to mention that germinate in the half time that was planned. The next, please. In the following, in this imaging, we can see on the left the tray with lettuces and normal plants on the right and below the inside on the control box. This box, as already mentioned, as differently sensors to monitor the environment and to get an idea to what really happens inside the box. As the next, please. Well, on the next, we find a graph on the internal environment of the control box in the orange, and we can see the temperature, and the yellow, the humidity date, and the green, we can observe the humidity on the ground and inside the control box. As you will see, the project already carries and the great advanced focus on the procedures for analog missions. As this project is extensive and can participate for this continuous improvement. And there are several sectors where it can be used. The most relevant or the highest priority are the student programs and the science part in the agricultural sector, and could obviously into lack of analog missions, wherever the case might be, can contact by email to my partner of me. And why to finish our presentation of plan of ground for long-lasting missions in space. I hope of you liking, and remember to take care. This is finished.
Wow, a lot of congratulations to you both on an excellent presentation. The visuals were stunning, love them. Let's see, questions. I'm just going over here. We've got about 5-6 minutes. Some people are commenting on surface temperatures. Jerry Stone saying surface temperature can reach as high as 35 C. And then Pavel says we'll go below 0 at night. Not sure that's a question, but they're engaged in the presentation for sure. Another person says, curious to see how nanotech can be integrated for soil, water, nutrients, and light. Any thoughts on that?
Okay. Well, for sure, there's a lot of applications in nanotechnology in For example, I remember that some research being done here in Mexico has made some like microspheres where they encapsulated certain components in there. For example, some antioxidants between other components I don't remember right now, but they proved useful when you add it in the soil where plants will be cultivated, and it helps them, for example, to fight against microbes, and they help them with their nutrient uptake capacity. So yeah, there's a wide range of applications for nanotechnology in this kind of research, mainly in the substrates and the way that nutrients can be delivered to the plant more effectively, and even more so in microgravity conditions.
Okay, let's see, another one. What about greenhouse arcs in orbit around Mars? Is that possible?
Greenhouse what? Sorry, pardon.
Yeah, arcs, A-R-C-S, arcs.
Arcs?
Well, I think they're, what about greenhouses in orbit around Mars? I think that's what the question is about. Inara, would you like to clarify that question for us?
Oh, well, architecture for the apps?
So basically what I was asking is, what about building greenhouses in orbit around Mars? Would that be something that would be possible for us?
Yes, of course.
And I only ask that because I think, keeping something in orbit would be a lot easier first stage than landing it and working with the soil in Mars. What if we could import our own?
Okay, yeah, of course, thank you for the question. Yeah, we think it would be also a very good approach. Maybe we could do some studies like setting up a greenhouse on Mars with all these special conditions so the plants don't die because of the radiation and other conditions from the planet, and another experiment where we have similar systems in, for example, maybe a little CubeSat or satellite that goes around the planet in order to, for example, do some research in how the difference in microgravity from in the surface of the planet and the satellite that is orbiting the Mars. How much does those conditions affect the growth of the plants, and if the approach related to the satellite greenhouse is better than the one in the ground? Well, we maybe propose keeping that greenhouse up in the Mars orbit. Yeah, of course, there's a lot of other area of research in there.
Okay, another question from Wayne. Have you exchanged any seeds with the University of California or the University of Alaska? And we've got about 1 minute left.
Okay, well, thank you for the question. No, we haven't gotten any seeds from abroad. We only have trying to get seeds from Mexico, like for example, from some endogenous plants like the amaranth. But it will be really interesting for us to obviously incorporate more plant material from plants coming from other countries and other regions to see how well they fare in our device. It would be very useful for the knowledge that we can get out of the system.
Only for information studies, the resistance.
Oh, I'm sorry. I'm not sure who that was. We're out of time. It's exactly 3 p.m. But I want to thank everyone for being here today. And again, thank you both Alejandro and Federico for a fabulous presentation. And we hope to hear from you again soon.
Thank you very much.
Thank you. Take care.
You too. Thank you for assisting in this session.
Thank you.
Of course. That's what I'm here for. Goodbye, everyone.
Bye.